So we're going to start with definition. For a function f from a to b and a subset c of a, the image of c is defined as f of c, f of x, where x is in c. Therefore, we can see that f of c is a subset of b, your codomain. And in the special case where c is equal to a, then f of a is the same thing as the range of f. So in terms of your visualizing your function, remember, here's your domain A, here's your codomain B. Remember, you have arrows that are matching up elements here. So maybe, I don't know, my function does something like this. And so what you're doing here is you're taking a subset of A. So, for example, maybe I'm taking C to be just these first two elements here. So C, you're taking a subset of A, and you're looking at the images of just these elements. So you're forgetting about that third element that's not in this set C, and you look at where those arrows go, and those arrows go over here. So this would be f of c. So it's definitely contained in B. And if I had taken the whole set of A, then I'd be looking at the images of all the elements of an A. So I'm talking about the range there. All right, so let's look at an example to make sure we understand this definition here. So for the set A, which is A, B, C, D, and E, and the set B, which is going to be the numbers 1, 2, 3, 4, 5, and 6, consider F, which is going to be A3, B5, C2, D3, and E6. Consider F, which is a function from A to B, and I want you to find the image of the following sets. C1, A, B, and C. So you're going to look at the pairs here that have an A in the first coordinate, A, B, or C. So those are the only elements within A, a B, or a C. And so for these coordinates, you're going to turn around and look at the second coordinate, 3, 5, and 2. So that is going to be your image, 2, 3, 5. I'm just going to write them in ascending order. Another way you might want to look at this problem is using the visualization of this function. So let's visualize this function here. Here's my set A, which has an A, B, C, D, and E. My set B, which has 1, 2, 3, 4, 5, and 6. And now we're going to fill in our arrows. A, there's an arrow from A to 3. There's an arrow from B to 5. There's an arrow from C to 2. There's an arrow from D to 3. And E to 6. So here I'm only looking at A, B, and C. So I'm only going to look at A, B, and C and see where do those arrows go. Coming out of A gets mapped to 3, B gets mapped to 5, and C gets mapped to 2. So 2, 3, 5 would be my image of my set. All right, let's look at the next one. B. Let's say my set is just going to be AD. So again, you have two options. You can look up at your ordered pairs here. So let me erase these colors. I just need A ones. Look at the pairs that begin with A or begin with D. So there's two of them. And what are their second coordinates? Well, they're both 3. You don't have to write 3 twice. So f of C2 would just be 3. Or you can look at this, again, this visual picture here of your function. You're looking at the element A and the element D. Where do those arrows go? They both go into the element 3. All right. Let's do 2 more of these. So C, C3, E. So you're just looking at what happens to E. So if I look here, E goes to 6. So F of C3 would just be the element 6. And finally, our last one is if I take C4 to be the whole set A, then F of C4 would be the range of F. And in that case, I'm looking for anything that has an arrow coming in to it. So let me erase. I don't need that anymore. I'm looking for anything that has an arrow coming into it in B. So 6 does, 5 does, 3 does, and 2 does. But 1 and 4 don't have arrows coming into them. So this is going to be everything but 1 and 4. So 2, 3, 5, and 6.